Hey y'all, it's T-Bonosaurus here. We got your 118, sine, cosine, tangent. So this is a little bit of what I was talking about before with the SOHCAHTOA. So I want you guys to remember SOHCAHTOA because it is quite important. In fact, we have it right here. Sine, opposite over hypotenuse, or my SO. Okay. Cosine is adjacent over hypotenuse, or my co, or my ka, and then my toa is my tangent, which is opposite over adjacent. Okay, SOHCAHTOA, SOHCAHTOA, super important. The reason why this is helpful, so as you can see in this example, you get 0.6, 0.8, and 0.75. Okay, these ratios, these decimals, okay, are very helpful. Now, what sine, cosine, and tangent actually do, okay, is they are all there is 180 degrees in any triangle, right? 180 degrees in any triangle. And when we're talking about a right triangle, okay, we have 90 degrees right here, okay? Because sine, cosine, and tangent are only ever going to work in a 90-degree triangle. So that means we only have, is this still working? There we go. We only have two variables, an x and a y is what I'm going to put here. I don't know why it's going slow. I don't know what's going on with my guy. All right. In any case, I have two variables. Now, because of similar triangles, you can draw this triangle, okay, essentially 180 different ways, right? So you have, or something close to that, right? I have one degree for y, and I have 179 degrees for x, okay? And it's even half this. So it's only 90 degrees because as it goes back through, I have angle 2, I have 178, okay? And what somebody has done is, and technically there's really infinite because you can go in between this. You could have 179.5. You could have, all sorts of different things. 178.5 actually. But people have figured out exactly every single option using calculus in order to figure out every possible option for these two angles in a right triangle. Then, because of all triangles with the same angles are similar, they are able to figure out that if the ratio between the opposite leg and the hypotenuse is 6 over 10, or 0.6, then that means that they can use what they know about sine to give you the angle, okay? And so when you go ahead and you are able to put this into a calculator with 0.6, it'll give you the angle that you're looking for. Now, the important thing when you're doing that, and I don't know if the book is actually going to bother telling you about it yet. No, they're not. They're not going to go into arcsine yet. But so, later. All right. So here's a calculator. If I know, and the second part of the problem is, if I know my sine is 30 degrees, or my sine is an angle of 30, I can do that. Oops, sorry, it needs to be in degrees. Degrees is important. We don't actually care about radicands. Sine 30, and I can get 0.5, okay? Please make sure you hit degrees. If you don't hit degrees, all of your stuff is going to be messed up. So 0.5 is that ratio, okay? That ratio is really, really helpful for figuring out our angle, okay? Or to figuring out the length of the sides. But if I know this and I don't know my angle, what I could do is I can do inverse sine, or it's called arc sine. Remember, arc is going to be like is going to be an angle, essentially the arc of an angle. And I can put in 0.5 and I get 30. Okay? So it goes both ways. Now, I don't think the book cares to show you about the arc sine just yet. But that's the whole point of this. The whole point of this is to be able to, people have mapped all the different possibilities, and using calculus, they've mapped it perfectly so that we can then go ahead and say, hey, if the ratio is 0.6, then I know what my angle is going to be. Okay? If my ratio is 0.8 for my cosine, I know what my angle is going to be. My tangent ratio is 0.75. I know what my angle is for A. So as long as you know two measurements, you can find all of your angles. Okay? And as long as you know your angle, you can then find the ratio to tell you what these numbers are going to be. Now, here's the problem. You need at least one number and one angle to solve everything. Okay? Or you need two numbers, okay, in order to get the ratio, okay? So if I have an angle, if I have a triangle, and I know this is 3, and I know this is a right angle, but I don't know anything else, I'm screwed. I can't actually solve this. If I know two numbers, 3 and 4, okay, now I can solve the whole thing. I can figure it all out. Okay, one, I can use Pythagorean theorem to figure out this, which is going to be 5. Or I could go ahead and I can use my trigonometry to figure out the angle here. Okay, this angle. Let's go ahead and do opposite over hypotenuse. So that's going to be my cosine. Oh, sorry, that's my sine. So if my sine is 3/5, I can go over here and I can do inverse cosine, make sure it's on degrees, 3 divided by 5. My angle is 53.13, okay? Or roughly 53, okay? Now, if that's my angle for one, how do I find my angle for the other? Well, I could either do, I have two things I could do, right? I can try and use trigonometry to figure out this angle by doing the sine of 4/5, because now this is my opposite, and this is, of course, still always my hypotenuse. Or what I can do is I can remember 180 degrees, 90 plus 53 plus x equals 180, right? And I can solve, okay? That is basically what trigonometry is and what you're trying to do. With what they want you to do, okay, if you're trying to use calculator to find the sine and cosine of angle A. Okay, so here I have the angle of 35 degrees. So I go over here, refresh this, make sure it's on degrees, okay, and I do my sine of 35, okay, is going to give me 0.57, okay. My sine is 0.57 over 1. Okay. Why is it 0.57 over 1? So that's a great question. I don't like that they're using 1 here. I think it confuses things. What you would do is if I really hate that they're using 1 there. That makes it, in my opinion, more confusing. Okay, so what they're doing here is they've given you that the ratio is 0.57. Okay, 0.574 is the ratio. Well, the easiest way to write that ratio is 0.574 over 1, right? That's that ratio. So that means that your side length must be 0.574. Now, let's go ahead. Let's do an example. What if instead we had a triangle where this was 2 instead? How would I figure out my side length here? Because it would not be 0.574. Instead, I have this is 2. That's 0.74. Okay. I have to take this ratio, multiply both sides by 2 to get my answer. Okay. So if this is 2, then my answer here is 0.574, but it is instead, times this by 2, 1.14. Okay. If I had a slightly longer one and this was 3, I would take that 0.574 and I'd multiply it by 3. Okay. And that would give me my ratio. Okay. And that would give me my number. So that's why I don't like that they use 1, because I think that's a huge important step to know that your ratio is not just your answer. That ratio needs one more step to actually find the answer for. Let me go ahead and I'll do the practice set in another video that you guys can watch. Okay. So I'll upload that in a bit. Have a good